All right, so I presume this is being recorded. You guys can still hear me?
Yep.
Okay, good. So we're going to start off the discussion today with Neal Adams. Last week, he gave a presentation on the various reasons and evidences for the growing Earth. So Neal, why don't you start us off?
Okay. You have to understand that if you're going to present something that goes completely against current standard science, it's going to be hard to find clues because everything that's done, produced by science, current science, is going to support the standard theory, which I guess is probably the right thing to do. So finding the clues to an alternate theory becomes very, very difficult. So what I'm going to do very quickly here is do two quotes, if I may, to get this started. Okay, this is a quote from Dr. Edwin Colbert, Curator Emeritus of Vertebrate Paleontology for the American Museum of Natural History. You know that museum down the way here. Quote, "The world of the Mesozoic was one world climatically just as it was one world geographically. It was largely a subtropical and warm temperate world. During the extent of the Mesozoic, there was a uniformity of climates. When dinosaurs ruled, there were no polar ice caps, while tropical, subtropical, and warm temperate climates were extant across the Earth from pole to pole. General uniformity of Mesozoic climates was associated with a uniformity of topographical lands, generally were low with no great elevations above sea level. There were hills, but probably no great mountain ranges to act as barriers to the circulation of moisture-laden winds or to the movement of large active animals. The uplifting of our modern mountain systems was to begin during the final stages of the Cretaceous history and to extend to the early middle stages of the Cenozoic era after the dinosaurs became extinct." Now, of course, what he's saying there is there were no mountain ranges before our modern mountain ranges, and they began to rise up about 60 million years ago. That is, for me, a Sherlock Holmesian clue because all of geology says, no, we have had mountain ranges for billions of years. Now, this is another quote, and I apologize because I just wrote this down briefly from the internet the other day, and it has to do with the Journal of the Proceedings of the Royal Society having to do with paleontology and fish fossils. The really weird thing, this is part of the quote, "The really weird thing that we found that is most surprising, that may end up being the most controversial, is that all marine ray-finned fishes that we see today appear to be derived from a freshwater ancestor." Now listen to this carefully, please. This is from February 7th, the Journal of Proceedings of the Royal Society, B. Quote, "About 180 million years ago, the first unambiguously marine, that is saltwater fish, in that lineage starts to show up." Okay. It's not until about 110 million years ago, 70 million years later, that a group of fish called Precamphora, which now includes 40% of all bony fish, started to diversify in salt water. Now, the problem with all of this is that, of course, up to that point, we had freshwater fish on the continental plates. That saltwater fish were a surprising development and didn't show up until beginning, if at all, 180 million years ago. But if we look into the deep oceans, we can't find fish fossils that are older than 70 million years old. That is saltwater fish fossils. Now, that again is a clue. And these are, as I say, it's very, very difficult to find these things if all of the sciences are headed in the same direction and that direction is wrong. uh, in ancient days, when you looked up at the sky and you would say that the sun goes around the earth, well, it's very clear the sun does go around the earth, doesn't it? It's part of the vault of the sky. The sun and the moon and the stars and the vault of the sky go around the earth, and the earth is in the middle. But of course, all it took was one person discovering that that was not the case for everything to be turned upside down. Here, our mistake was we looked at Hubble and we said, oh, look, the universe seems to be expanding. And if you make that assumption or you make that deduction from the fact that the universe seems to be moving outward, you could be making a mistake. And that mistake would be, doesn't expanding or moving outward look exactly the same as growing? In other words, if the universe as an entity, the matter universe, is actually growing, then it looks like it's moving outward. Or to put it another way, if you were an atom on the shoulder of a baby that's 1 year old, and you could see the atom on the shoulder of that same baby by putting your telescope on it, then a year later it would seem as though the baby were expanding, but the baby is just growing. That is true also with the Earth. 180 million years ago, there were no deep oceans on Earth. This map that you can get on the internet is a crustal age map. Crustal age map shows in the yellow, red, green, blue, shows the spread of all of the oceans on the Earth. If you look, it's a little hard to see, I understand, but if you in North America, in the Atlantic Ocean, you can see that North America and Africa, the two coasts, not South America and Africa, but North America and Africa, is the first spread of the Atlantic Ocean. And there is an area that is 180 million years old, 170 million years old, 160 million years old, until finally you get some more spread down by South America. In the Pacific, right over here, that triangle, I don't know how hard that is to see, and I apologize for it because we're very limited here. That triangle is the oldest spread in the Pacific, and right in the middle, that little area right there, is 180 million years old. It is not gone. It is not subducted. The subduction zone is right over here. Okay, but that is 180 million years old, and around it is 170, 160, 150, 140, and on outward. And that is a triangular spread indicating, just like in the Atlantic, where you have two sides, here you have three sides, then it's a three-way spread. North America, Asia, and Australia, the Australia, Antarctica giant supercontinent moves the way down this way. So that is the oldest Pacific. Now you could say, well, the Earth ate the other older ocean plate. Well, it didn't, because it's sitting right there. It's right there. And nothing about the geometry, which you really have to study all of these things. I mean, one of the things that I had to do in all of this is I really had to study all of the sciences, including the graphic sciences and everything else. But there's no way you can interpret that as being, well, there's some hidden strange shape within that indicates that there's older ocean anywhere. The oldest ocean is right in the middle of that triangle. Another clue, Sherlock Holmes would say. But of course, we need more clues. One of the clues would be that there were no mountain ranges. There are no evidence of mountain ranges. Geology tells you, no, we've had mountain ranges for billions of years. No, you don't really. You might have what you call clues or what you call indications, but in fact, there are no mountain ranges that are over 60 million years old on Earth. There's land that made the mountain ranges that's older than that, but the mountain ranges themselves were no older than 60. And if they were, then you could not have the free migration of dinosaurs. That is one of the major explanations of Pangea, which is Pangea is the theory that we're basically contradicting here. You cannot have free movement of dinosaurs across mountain ranges. It's sort of like saying, well, oh yeah, dinosaurs could get to California from New York. Can't do it. There's a mountain range in the way. In fact, mankind couldn't do it, and they had furs and all kinds of other artificial things to get. No dinosaurs could cross that mountain range. If there were the Appalachians or the Himalayas, if all those mountain or other mountain ranges existed, then you would not get free migration. And one of the tenets of the Pangea theory is that dinosaurs could travel freely to all 7 continental areas of the world back in the Triassic. So many of the things that are being thrown to us as theories, while having clues, are contradicted by facts. And one of the things that I do, or I try to do as much as possible, is to study the facts, because the facts are a lot simpler. There's fewer of them. They're very basic, very understandable, and very good. And so they're easier to get. They are. If you say, and this is what I ran into, I got to tell you, I went off from Samuel Warren Carey. Some of you may know Samuel Warren Carey's work in the 60s, who was the first guy to come up with the expanding Earth theory. But of course, he was a geologist, and to a geologist, expanding might be a good word, but of course, to physics, it is not a good word. There's no such thing as expanding in physics. You would have to take the other choice of words, and that would be growing, because there is no other word. Unfortunately, physics does make one exception to that, and they say, well, the universe is expanding. So apparently the one exception to the expanding rule is the universe, which I find actually funny. Anyway, if Earth is a microcosm of the universe, if Earth is a microcosm of the universe, then what is true for the Earth is true for the universe. And if it is true that the Earth grew, then the universe grew, and everything we know about science has to change. And that's what we're talking about here today. So if anybody wants to question me about it, go right ahead.
All right. Thanks, Neal, for your introductions. So I'd like to ask, does people have questions for Neal?
Am I crazy?
Any questions out there? Or does everyone just simply agree with what Neal is saying?
Please don't. Please don't.
I completely disagree.
Good, good.
As long as you don't have a mechanism that creates matter, or at least that fills the Earth to make it bigger, and you cannot explain that mechanism, what you are stating is.
But you didn't ask me if I could explain that mechanism, no?
Yeah.
You didn't ask me if I could explain the mechanism.
Yeah.
Yes? Okay, and I can. You see, because let me just say this parenthetically. When I started this little journey, I had just heard about Sam Carey's theory, and I realized that when subduction was discovered, Sam Carey was essentially shot down. Not that anybody contradicted him or could prove that he was wrong, because he was too good a geologist to do that. They simply ignored him. They said, no, what happened was the Earth ate its own crust. Every bit of 2/3 of the Earth's surface it ate. Every square foot it ate. Somehow a Pac-Man type of creature went around the Earth and ate every bit of ancient ocean crust back 700 million years or more, magically ate every square foot, and you, Sam Carey, are incorrect. Okay, so I thought, you know what? It's going to take it's going to take a physicist to help Sam Carey, because otherwise, how is he going to prove he's right? And Sam was a geologist; he couldn't pop up with an answer. But I thought, if you have a failed theory, who the hell is going to help you? Really? I mean, if you were a physicist, would you try to help Sam Carey once subduction was discovered, and throw away your career on trying to find a mechanism for him? So I thought, you know what? I'm going to do it. I'm going to find that mechanism. I'm going to study all of the sciences, and I'm going to do that mechanism. Are you, sir, a physicist?
I'm a physicist.
Okay, good. Okay.
I'm a trained physicist.
Okay, excellent. I am trained, but I'm not a physicist. I haven't gotten the degree, so I'm going to talk to you about physics from the point of view of somebody who is actually. They allow you to read the books. I don't know why, but they'll give you the books, and you can read them, and you can study that stuff. It's amazing what they do. Let us say You know the concept I'm sorry, I can't get it. In pair production, you have asymmetry.
Neal,
You know of asymmetry?
Neal, can we slow down a bit?
I'm sorry, what? You know of
Why
asymmetry?
don't you ask him what his objection is before you try to refute it? What is the objection? That's what I'm trying to understand.
The objective or the
What
objection?
is the objection? Stated
His
clearly.
objection
What's
is
the
that
objection?
his objection is that he needs a mechanism. Yes?
Well, what does he mean by that? Doesn't mean anything to
He
me.
needs a mechanism of matter creation. Yes?
Oh, okay. Is that correct,
Okay,
Hans?
that is
Yeah,
it.
that's correct.
Of course, I've been having this
Okay,
debate for
but
30
you're
years, so I
assuming.
know I know it. So we
Okay,
have
hold
in
on, Neal.
physics,
Hold
we have
on.
I'm sorry.
His,
In physics, we have what's called
the assumption.
asymmetry. Okay. It seems as though all the electrons in the universe were made of by pair production, unless somebody can come up with a new theory or observation. The only way you can make electrons is through pair production. At the same time, you also make positrons. So during the process of pair production, which can happen in space, can happen anywhere, what happens is a high energy photon strikes some invisible something, we don't know what it is, okay, and splits it in half along with the energy. One half of the energy plus one half of an electromagnetic field becomes the electron, and the other half of the energy plus the other half of the electromagnetic field becomes the positron. So now we have an electron and a positron, we have matter. As far as we know, it is the only form of matter creation in the universe, as far as we know. Is that correct? Am I correct, sir? Essentially.
I have another explanation of
Okay, I don't.
and pair annihilation.
Okay,
And
but
that's a
let's just
zigzag.
stick with standard. Can we just stick with standard science for the moment? Is that okay? I know there's lots of theories around here, but
science. It is standard science.
yeah, I just want to stick because me and standard science, because you are a physicist and I'm debating you from that point of view. Okay.
Yeah.
Now what we have is essentially an electron universe, because we have so many damn electrons that they make up more than 1/3 of the universe. Okay. So if I were to say pair production gives us the universe, you would have to say, well, it is true. It gives us more than 1/3 of the particles of the universe happen by pair production. I argue that no, it gives us all of the particles of the universe. So you would then say to me, well, but there's no positrons. And I would say to you, well, maybe they're hidden in plain sight. Maybe they're hidden in plain sight. Then we have another, and I'm going to jump off of that for a minute, okay? Then we have another process that creates protons, okay? We don't know what that process is, because apparently we're calling the things that make up a proton quarks, right? So from my point of view, being a Sherlock Holmesian type of guy, I would say, okay, where did these quarks come from? I mean, and who made them? Because are we saying that the universe periodically goes out and makes up these strange particles that somehow fit together and become protons? Or is there a simpler explanation? Is there a simpler explanation? Because, you know, there's a very simple explanation for electrons, but somehow there seems to be this complicated, weird, creative process that goes into making protons. So I would say this: there's no such thing as a quark. I don't, any more than a snowball is a snowflake. I think that protons are made of many, many particles, and in fact are made of many, many pairs, okay, of particles. They are those same particles that make up the electron and the positron in pair production. And at the core of each proton is a positron. Now, science has detected a positive force at the core of protons. You'll agree? I say that force, that thing at the core of a proton, is a positron. And that's where our positrons are hiding. Well, you have to go down a whole new trail of scientific discovery to get there. When I started this process, it was 35 years ago. Okay, 35 years ago is a good deal of time to think, good deal of time to eliminate, to take this theory and throw it away, and this theory and throw it away, and this theory and throw it away. When I did all of that, I came down to pair production. And in pair production, we may have the answer. In fact, we would have to have the answer, because there cannot be asymmetry. You know that. There's no asymmetry. There's exactly the same number of positrons in the universe as there are electrons, because the process that makes them tells us that one of them gets one half of the electromagnetic field and the other one gets the other half of the electromagnetic field. And if you were to put them together, you get a whole electromagnetic field. And
so, Neal, can I interrupt for a second?
Sure.
Because, you know, I like what you're saying, although I think we could simplify what the proton is even further by just saying that a proton is just two positrons and electron.
No, I cannot.
Why not?
Because you'd have to build because of the size of the proton, you would have to build a structure around a positron, which you can do, by the way. If let me describe what I would call a prime matter particle, or the field that exists before it is struck by the high energy photon. Okay.
Well, the thing is, you have to explain the mass difference, right? You're explaining that.
Yes. Oh,
proton is 1,838 times.
I better, right? Because that would be stupid. Okay, so you have a particle that you cannot see and you don't know is there, but fills the universe and in fact makes the universe. You can't identify it because it's an in-facing field. That is, the point particle that's at the center is the positron. The particle that goes around, that is around it, okay, is the electron. Now, how did this get made? I have no idea, because I'm not God. I would guess, well, what about spin? Spin pulled the universe apart and made these little bubbles, and these bubbles are what it's too much for me, because I don't like theories, okay? But something made these things, okay? Made these little tiny fields. And in making these fields, it explains the universe. So you really have to go with me here. If you have these little bubbles and you have the negative electron on the outside shell, of course it's not a shell, it's one where one part of the field ends and the other begins. Then you have the point particle in the center. You have the positron in the center. You have the electron on the outside. So you have a ball, essentially a ball, and in the inside is the point particle. That's the positron. High energy photon comes in, penetrates the shield, and knocks the positron out. Now suddenly the two fields are exposed. The positive portion of the field is knocked out, so its field now flows outward, just as the electron's field flows outward. So now you have an electron and a positron, okay? We call them matter, okay? So if you imagine such a structure, imagine the high energy photon. Now what happens is each one of them grabs onto half the energy because they've lost the other half of the field. So they're going to grab onto that energy. Each one is going to retain that energy until they come together again, and they'll throw the energy off because they don't need it, because now they're fulfilled or they become whole again. So now you have a negative particle and a positive particle with fields going outward. And what does a particle whose fields are going outward mean to us? They mean it's matter. That's how we identify matter. It's a particle that has a field that flows outward. If it's an inward-facing field, we can't see it. We can't identify it. So if we have this structure that I described, the electron on the outside, the positron on the inside, we can't identify that field because the field is flowing inside the particle, not flowing outside. Maybe at a galactic level, some of it gets away, but essentially it's not going to come out. It's going to stay within that particle unless you knock that core particle out, and now it floats out by itself. Now, if either of these two particles come near one another, or others like it, they will join, okay? They will actually they will come toward each other. They will revolve around each other, creating for a very nanosecond or less than a nanosecond what we call positronium, which is very much like a hydrogen atom because it has an electron and a positron. It's like a hydrogen atom, has the same strength, same validity, okay? And then it seems to join together, disappear, and 2 gamma ray particles fly out, okay? Now I say to you this, people need to study this structure, okay? If I'm wrong, it can be proven, okay? But it has to be thought about, because if you think of the universe as being complicated, sophisticated, and well thought out by some creative entity that creates a universe out of complicated particles that it just generates out of nowhere and puts together into little pies, I say no. The universe is simple and stupid and non-creative. It creates one miracle for us, one miracle, pair production. And out of pair production, we build a universe. And I will also say this. I decry the idea that science, once it saw its goal, that is, now we're down to 3 particles, now we have to go to 2, now we have to go to 1, now we have to go to nothing. Somehow the fantasy of discovering new particles was like monkeys with shiny stones. They suddenly discover these new particles and they go, oh, wow, we got lots of particles to play with, because aren't we going to have fun? I would say no. That is not the goal of science, okay? The goal of science is, now that we're down to 3, get down to 2, get down to 1, get down to nothing, because that is our goal, okay? And it seems to me that the eye has been taken off the ball. I'm a simple, basic person. I don't believe in all of this theorizing. I don't think it's good for people, and I don't think it's good for science. I think it's good to take all of the areas of science, bring them together, and track it down to its core. And that's what I've tried to do. And it's taken me 33 years.
Now explain to me again.
Yes.
What is the mechanism that turns a field into an electron or a positron or a quark or something like that? What is that mechanism?
Okay.
That turns it up and
The
down
mechanism is
from
pair
a field
production.
into a particle. How does it work?
The mechanism is pair production.
Well, now, what is pair production? What is the mechanism of pair production?
Okay. A high energy photon.
What does this?
Huh?
What does this?
Well, we do know what
one
happens.
thing into the other.
You're asking me where the high energy photon comes from?
No.
What do you ask?
What turns a photon into an electron? How does it occur?
Nothing turns a proton into an electron.
How does it occur? What's the mechanism?
For which part?
No, I think he's talking about, he's asking what is he's asking for the physical mechanism why you can eject positrons and electrons from seemingly empty space.
It's called pair production.
He's asking for the mechanism, although personally, since we've experimentally shown that happens, I don't think that it's necessary for us to explain how it happens. As long as experimentally know it happens, I think that is sufficient for the purposes of your theory.
Well, yeah. I mean, pair production happens. Pair production happens everywhere. It's such a common event that you can say it happens everywhere all the time. And I would say this: if it happens everywhere all the time, all you need for pair production is energy. Okay. As soon as you have energy, you have pair production. I would deduce from this that the fields, those little in-facing fields, are everywhere. They make the universe, because all you need to think about, deduce with me, okay? If I say to you, I'm going to make a lightning bolt, okay? I'm going to make a lot of energy, okay? If I do that, wherever I do it, I get pair production on a grand scale. If I make a lightning bolt, I get pair production. That means that the elements to make the rest of those pairs, not just the energy, but the field, is everywhere. Those fields are everywhere. We can't detect them because they're in-facing fields. So we are the fish that swim in the ocean of fields, and we can't identify them because they are the ocean.
So every light bulb is an atomic bomb?
Every light bulb isn't it? Well, I think that Einstein would say yes, that's true. You're correct.
That's not true.
You break the elements of a light bulb down, and you break down its molecule particles. Yes,
you're nonsense. It's not true.
In favor of that, but there you go.
It doesn't turn into a particle.
What doesn't?
a field doesn't turn into a particle.
Apparently, in pair production, it does. It's a
Oh,
truism. It's got nothing to do with me. I didn't do it. It was first observed in 1932 by Carl David Anderson, and we've used it ever since. Of course it
yeah,
does.
but that's not just a turnover from a field into a particle. You
No,
misunderstood.
you need
You
energy and
misunderstood the whole thing.
you need energy and you need the field. That's how you get the particle. Not
No,
because of me.
the
I didn't
field,
invent this. I didn't discover this. I'm sitting on the sidelines watching it happen.
the
In
field is nothing
1932,
else. The
in
field
1932, Carl David Anderson first observed part of a pair production. It's been
listen.
observed thousands and millions of times. You can actually take positrons and collect them in colliders. They can be collected. This is not something that I'm involved in. I'm observing it from the outside, and
A
I'm saying,
field
okay,
is
well, how do
nothing
you make
else than a
this?
carrier.
I'm sorry, what?
A field doesn't create. A field is a carrier and can vibrate. That's the only thing that it can do. It can deform and it can vibrate. It doesn't create particles.
I didn't say it
So
did.
Hans, where
didn't
do
say
you
it
think the
did.
particle comes from?
The particle comes from a combination of energy and a field. Yes, that's.
I don't get a chance to get a word in between.
I'm sorry. I
You're
apologize.
talking the same story,
Go ahead.
but the field is just a carrier, something that can vibrate and can deform. And the things that deform it are landings of uh, locations that do not have the proper ordering. It is another field that is reduced to small points, and that's disturbing, triggering a carrier field. And that carrier field is reacting to that disturbance with vibrations. And these vibrations are small, and if there are sufficient of them and they're getting into swarms, then you get a particle. An electron is a swarm of disturbances of a field. The
It
field is
sounds to
nothing
me
else.
like pardon me if you don't mind me saying so. It sounds to me like you're presenting a theory of your own.
Yeah,
Is that correct?
yeah.
Okay.
It is.
I'm not involved in other people's theories. I'm not. I have to say I'm just debating with standard theory. As far as you being a physicist,
Yeah,
you represent
but also
standard theory.
standard theory doesn't. You don't listen to the standard theory as well,
No,
because
I do.
fields are just carriers. They react on charges. They have charges as sources.
How do you get pair production?
A field doesn't turn into a particle.
Fine. Explain how you
Well,
get pair production.
Can
A
can we
vibration
take
of a
can we
field.
take this can we take this discussion more back to whether this has to do with expanding Earth theory rather than atomic physics? I mean, just to kind of summarize what I've been hearing is that, Hans's objection was that he doesn't believe that the Earth is expanding because there
We
was
don't
no
have a mechanism.
mechanism presented to say how mass could be created. So what I heard from Neal was that he's saying that mass is created, generally speaking, in the presence of energy. So inside the Earth,
Right.
positrons and electrons are being created, and then those are creating electrons and protons somehow, and those ultimately become additional matter. So is that plausible? I mean, I don't want to get too much into the nuts and bolts of why
Right.
pair production works, but
Right. Let me say this. Okay. The difficulty with all of this, and this is what happened with Sam Carey when Sam Carey presented his expanding Earth theory, is that besides finding subduction, which was really great for the geologists and the paleontologists, the physicists said, well, you have to give us a mechanism for growth, because they use the word growth, and Sam Carey said, well, this is expansion. I don't know how it happens. I'm just saying that geologically it happens. Okay, I can't explain it because I'm not a physicist. So I have gone into the physics and all the rest of it, and unfortunately, because of specialization, you can't talk to the same specialists almost in the same room with the other specialists because they just talk their specialty and they have a particular language for their specialty. I prefer to speak in common street English, and so I don't want to talk in those languages because there's too many and too many people have them. So in some weird way, the physics discussion, you sort of form a subcommittee and have those physicists or people who want to talk about the physics part of it go into that room over there and have their argument over there while the paleontologists have their argument over here and the geologists have their argument over here. And under those circumstances, how can you find a theory that explains the universe? The problem is that we've changed science so that we've segmented it to the point that nobody talks with anybody. I may be one of the few people in the world that talks science from the point of view of regular talk. And the problem that we're running into here is that we fell into this physics area, which I could go on for the next 3 hours talking about, but everybody else would fall asleep. And I understand that, okay? And I have to appeal to my physicist friend here to understand it as well, because you and I could continue to talk about subatomic particles and all the rest of it for ages here, but I think we have to talk about other aspects of the growing Earth. But let me say this, okay? It takes a long time to generate a real solid thought and a theory. So I am presenting to you the beginnings of this pair production and how it works into the creation of matter, because the alternate to that, to me, is magic. The Big Bang, the idea that the universe was created in an instant, the concept that the Wizard of Oz came down and went plunk and created the universe, to me, is illogical to any science, okay? It can't happen that way. It's stupid, okay? I apologize for the word stupid, but it's stupid. It really is stupid. The universe logically started with one particle, then another, and then another, until we have the universe the way we have it today. And if that's the truth, who turned off the off button? Who turned off the off button? And why is the universe growing exponentially, which is totally against standard theory? Okay, let's go back to all the other stuff. If anybody has any other questions.
Neal.
Yes.
You throw too many ideas together into a big pot and you stir them all up all at once, and it's difficult for people to follow.
I apologize.
And
they have to be there. You understand? They have to be there.
You have to sort of bite it off. Essentially what physicists are saying and is as follows. They have what they call laws of nature that they have discovered in a laboratory and observing the motions of the planets, et cetera, et cetera. So they've got these laws of nature. And so anything that is explained in accordance with physics has to be done in accordance with those laws of nature, right? What Hans is saying is there are no laws of nature that allow what you are asserting to be the case. Can we agree on that?
But there are, and it's called pair production. It's as simple as that.
No. There's no, but see, that's the point. The point is Hans doesn't agree with that because there's no
Hans does not.
Nature that
pardon me. Hans does not agree that there is pair production. He just says that's not the mechanism.
No. I do. It is not that I don't agree with pair production, but pair production doesn't occur the way that you think.
Wait a second. Are you saying that there is no pair production?
There is pair production.
Okay. Are you saying that matter is not created during pair production?
Two photons can produce, if they have a high enough energy, can produce an electron and a positron. That's what can happen.
No,
It can
no.
also create.
Hold on a second.
can
That's
also
not the premise of pair production. Pair production is a high energy photon, not proton, photon, which is
I
energy.
say photon. I said
Huh?
photon.
It's his accent.
Okay, it's
Sorry. I
photon,
said photon.
and that is energy.
A photon is energy.
Photon
A
is
photon
energy.
represents energy.
A
And
photon.
an electron and a positron represent mass.
That's right. So you pair
So
production creates.
what occurs at pair production is that photons, high energy photons, are turned into mass.
Hold on a second. Hold on a second. Hold on a second. Turned into. That's magic,
into.
sir. That's magic.
Yeah.
Turned into. No, there's no such thing as turned into.
Oh, good. I have another explanation, but
That's what I think we're talking about here, sir. I think we're talking about your theory, and that's not what I'm talking about. Okay, we have to agree that there is pair production. Not your explanation or my pair production exists. Was discovered in 1932.
Pair production.
And you get from it matter, 2 particles of matter.
Pair production that's measured each day. As long as the Large Hadron Collider runs, they have pair production each day. And
you don't need a collider. You can have lightning. It happens in your living room, sir.
A lightning normally do not produce pair production.
Yes, it does. It happens in your living. It happens in space. Wherever you have a high energy photon, you have pair production. Happens everywhere. They can make. You can look it up. I mean, pair production happens in space.
Well, I think the important thing here is that, Neal is saying that he doesn't basically have to explain pair production because we know it happens.
Exactly.
I mean, he's using pair production. I mean, you ask the question of what's the mechanism for the expansion.
Pair production.
He's giving you pair production.
But that is the only form of matter creation in the universe.
Do it the other way around. If you have matter that is turned into energy, do you know how much energy that is produced?
Well, once again, I don't think that's something that Neal has to explain.
Who cares? I'm not involved in the
purposes of his expansion.
We're talking about how things work.
You need an enormous amount of energy to create a little bit of mass.
Look, I understand all that.
And now you are creating a complete mountain of Earth from energy.
Yes.
What's the amount of energy that's required, and where does it come from?
Whatever the amount of energy that exists at the core of the Earth is the amount of energy that it takes to produce the matter of the Earth as it gets larger. Whatever that amount is, and we don't know what it is, but whatever that is, we can't go outside and ask for Chinese food to be delivered here and give us new matter. Whatever that process is at the core of the Earth produces the matter that creates the growth of the Earth.
What creates this enormous amount of energy that is needed to create that enormous amount of mass?
Well, will we agree there's an enormous amount of energy at the core of the Earth?
Yeah, but not that amount that is needed to create.
Well, I don't think you know, do you? I don't think you know, do you? What if I said to you that the core of the Earth is solid hydrogen?
Doesn't matter. Hydrogen is matter.
Well, if hydrogen processes into helium, how much energy do we have?
Fusion
Guys,
energy.
I got to tell you, I've studied this for a long time.
To build a mountain.
Any question that you have, believe me, I have an answer for you. No, I would say the core of the Earth.
Not an answer.
I would say the core of the Earth is a nascent sun. How about that? And that it's hydrogen, it's processed into helium, and that's where we're getting the energy to keep the Earth warm and to get that superheated core. That's the same hydrogen that we have at the core of the gas giants in Jupiter and Uranus and Neptune. We have solid hydrogen that's processed into helium that's causing those planets to grow. That's causing Jupiter to become the meteorite umbrella for all the inner planets, by the way, and it is the process by which all these planets grow. It happens inside the sun. That's why the sun grows. Wow, some people say the sun isn't growing. Yes, the sun is growing. The sun is growing and getting hotter. And so are all the suns in the universe. All the suns in the universe are growing and getting hotter. I mean, It's a process that's happening. It's like this stuff is in front of our faces. We just have to look at the facts. And believe me, I'm not trying to pick an argument with you. I'm saying pair production is a fact. It's not my fact. In 1932, I wasn't alive in 1932. That's when it was first observed. You can go to a hospital and it can be used to scan your feet. It's everywhere. It happens in lightning. It happens in the core of the earth. It happens wherever there's energy. You get pair production. The only question is, where are the positrons? Because there have to be an equal number of positrons to electrons in the universe, an exact equal number. And I say those positrons are at the core of the protons, and the way you get them there is through a theory that describes the process from pair production to creation of atoms and the creation of protons. And that is a journey that took me 35 years to get to. So you and I are having a discussion here where you're, in response to me, you're throwing your theory, which I'm sure is very interesting, at me instead of discussing pair production.
No. I don't criticize pair production and the fact that it exists. It exists.
There you go.
It hardly occurs in the center of the earth. It occurs inside.
So you're saying in your opinion, sir. You're saying in your opinion. And I say in response to that, pair production happens wherever there is high energy photons. There is energy. So if you're saying to me there's no energy at the core of the earth, I say to you, sir, we're reading different books.
No.
Of course there's energy.
There is more necessary than that enough energy is present, because these photons have to aim exactly onto each other, otherwise no pair production occurs.
No, they aim, sir. They aim randomly and they accidentally hit. If the universe is filled with these fields, they are everywhere. So all you really need is energy firing any direction you want, and sooner or later it will hit one of these fields. Because, and everybody please listen to me on this, pair production doesn't come from a high energy photon splitting in half, okay, and you get half the energy and half the energy, and that's an electron and a positron. That is not true. What happens is an event happens where it seems to strike something, changes its momentum, breaks in half, and the two clumps go in two different directions, and one gains a half field. The other one gains the other half of the field. Simple, common deduction, street deduction would tell you when these two half fields would come together, or before they were struck, they were a whole field. Otherwise, how could you get a half a field over here and a half a field over here?
Well, I would object to the idea that you can have half a field.
Well,
that doesn't make any sense.
What's an electron? Then what is an electron?
Neal, this is Harry.
Then what is an electron?
Slow down a bit, Neal.
Is an electron a half a field?
No, electron, I would say, is a specific matter particle.
That's
There's
not
no law of
physics.
physics
What is a half a field?
what you say happen. There's no law of physics that describes what you just said about fields. Do you understand what I'm saying?
Of course not. We're going into new science, guys.
That's my point.
Yes,
Neal. My point is people like Hans van Loonen don't want to talk about new science. They want to talk about their theory that they have based on what they think the laws of physics ought to be.
How do you feel about jumping off of the pair production thing and getting into any other areas? I think we've exhausted a bunch of this.
Yeah, I think we should move on.
The problem is,
but Peter,
I would be delighted to do it. I'd be have a great time. But
yeah, no, I do think we do need to move on. I mean, Peter Sujak has raised a flag, so perhaps he has a question he would like to ask.
I think this is resolved, Franklin.
I don't think we're going to resolve it in these 2 hours.
You never know.
You need to sort of get to some kind of an agreement.
Let me just say this: there's a lot of things in science that science does not choose to explain. They don't choose to explain how it's possible that the Earth 180 million years ago had subtropical temperature from pole to pole. They don't want to explain that there is no evidence for mountain ranges before 60 million years ago and the free flow of large animals, because they have theories, and that their theories want to support the standard theory. And the standard theory is that the Earth was the same size it's been for 4 billion years. And if that were the case, certain things would happen. And so they look for evidences that say that would happen. Most of those evidences are theories. They're not facts. The facts do not bear out their theories. There were no mountains before 60 million years ago. The climate was the same from pole to pole. How is that possible? How is it possible that there were no frozen poles? How is it possible there was no essentially winter? How is it possible? And of course, we have, the proofs that we have for that are that most of the plants, well, we have lots of proofs, but the plants were not seasonal plants. Somehow we managed to gain seasons 180 million years ago to 100 million years ago. We managed to gain seasons. That doesn't make sense, and it fits into that area of fact. There's fish fossils you can't go into the deep oceans and find fish fossils that are older than 70 million years old.
Well, Neal, let's see if we have some other questions.
Sure.
From the group here, because I really do want to get to other people's questions.
Glad to.
So, who else has got a question for Neal?
This is Jack Kirkendall. I'd like to move on to another.
Could you get closer to the microphone? I'm sorry.
Okay, how about now? Can you hear me?
Yes.
I would love to move on to another topic. This is just basically arguing over everybody's thought processes. Can we move on to a different subject, please?
Okay.
Well, I think we're still talking about, we still want some questions about objections to this mechanism. Now, we have kind of been getting into the weeds, but since we are a physics group, I think it was interesting to discuss the mechanism of pair production. But I see like Peter has raised his flag. Peter, did you have a question? No? Okay, well, so Adam, so Neal, I have a question. And so I did some Googling on the web. And so there are some sites that have some objections to your theory. So if nobody else has any other questions, I'd like to see what your comments are.
Sure.
So let me put that up and let's see what they have. So first of all, I have to get back to my control. I have to unshare that. And let's bring up this website of other objections. Okay, so here's a website. Have you seen this one? This is called HRF. I don't know what health research funding has to do with the expanding Earth theory debunked, but here's a bunch of objections.
Okay.
So here's an interesting one. It says high precision measurements disprove growth. So apparently they have tried to measure the movements of the Earth to an accuracy of 0.2 millimeters.
Yeah.
And they say that there's no growth in the planet at all.
Well, and I appreciate that, but I mean, if you get in a plane and you fly across the Pacific or the Atlantic Ocean, it becomes very, very hard for you to imagine that they have instruments that could do it that precisely. They say they can. I doubt it. On the other hand, there's another group of people that measure the gravity fields of Earth, and they say that the equator of the Earth has been growing for the last 19 years. There's a site, you can look it up. It says equator growth. Okay, so they disagree. Then there were almost like as if they spotted me and they want to prove that little old me, is wrong. So NASA jumped into it, and a bunch of people jumped into it. And there were 5 organizations that measured the Earth, and they said that, in fact, not only is the Earth not growing, we all have discovered that since our last measurements 5 years ago, the Earth has actually shrunk. Okay. Did any of them give the measurements? of this shrinkage? No, not anyone. Did they compare their measurements to one another? No, they did not. To me, I appreciate, that they're doing that, but you could put a rock in your yard and it would change the circumference of the earth by 24 inches. I don't even think that what they're saying is possible. I just don't believe the technology. Now, let me just say this. You saw the maps that I made. I am a very big fan of technology. I know the technology. I get the technology. I study the technology. Can you measure the earth and exactly down to the inch? I don't think so.
Well,
And
I put up they have a reference to that where they say, so this is I'm showing the actual paper that they're presenting. This is something called Accuracy of International Terrestrial Reference Frame, Origin and Earth's Expansion. So it looks like they're using like satellite measurements.
Right.
And so this is just might be something you want to take a look at, and see whether this explains how they're actually doing these kind of measurements.
But there's lots of sources that have this. This isn't the only one. I mean, there's a bunch of them. I had just recently had an argument about the GPS with a guy on the internet, and he was insisting that the GPS could easily, show that the Earth doesn't grow. Well, the GPS uses triangles, essentially triangulation or type of triangulation. It's got another slightly different name. You can't measure a circumference of the Earth with triangulation, so the GPS is really just a waste of time. And to go into it, it's hard. I mean, it's sort of like if you're presenting the concept that the sun goes around the Earth, unless you have the instruments to measure it, you can't do it. So they say, and by the way, when you read these articles, you'll discover, well, we do say that there is a slight growth. They're very, very slight growth. There are people in China and there are people in different places around the world that are estimating and calculating whether or not the Earth is growing. And I don't have the instruments to do it. And I don't think that I would believe my instruments if I could do it. I can tell you this, that this debate has been going on for a long time. And one of the things that is true is that up to, and I don't know if it's changed, okay, but up until the last couple of years, the satellites around the Earth are recalibrated every year for mistakes. As soon as they discover discrepancies, they recalculate their computers for their satellites. Well, if you're going to recalibrate your satellites, how can you get measurements and how can you depend on them? And can you explain why the measurement changed? No, you can't explain it. You just recalibrate it and set it back to zero, and you're done. This religious belief in technology is not, in my opinion, a good direction. It doesn't make any sense. And here, let me give you another one. Okay. You're going to differentiate granitic rock from basaltic rock around the whole planet in that molten layer that's under the crust. Differentiation turns solid rock into a liquid. That liquid is opportunistic. That is, anytime it finds an empty space, it will fill it.
Yes. Well, we actually already heard this last week, so I don't want to repeat things.
Okay. Well,
I just want to get to this. Because this is one of the objections. They're saying that satellite measurements are not showing expansion. Although, curiously, so I'm looking at this paper here. This is the first time I've seen this paper.
But that
and so
the expansion is continuous and not cyclical.
Well, even this paper shows an expansion, and it's like 0.1 millimeter here.
They're saying the expansion has to be continuous, and therefore they can observe it right now, but it could be cyclical. In other words, it's not occurring now, so they go and they try to measure it, and it's not occurring, therefore it doesn't happen according to them, right?
No, they're saying that they measure this with satellites. I mean, satellites.
How can they do that? They can only measure it for over a short period of time.
Well, you can absolutely measure the distance to millimeter accuracies from base stations to the GPS satellites. I believe they can do that.
And they show
that there are like a whole constellation of these satellites around the Earth. And I would believe
it's not necessarily expansion right now. Suppose
well, no, not necessarily. Well, I believe that's a different argument. The argument that Neal is presenting is that he doesn't believe that they can actually do the measurement, not that the measurements
And if
itself is in question.
and they're showing an increase already, and you're according to this, not as big as I would say, but
No.
an increase.
Yes, not as big as you would say, but it's there. So that, you know, they have,
Well,
like I said, I think this might be interesting for you to take a look at, because I think this does have some information.
well, I'll do
You
that
know-
if everybody else will look up at the expansion of the equator, according to the gravitational measurements. Just look up equator growth on the internet, and you'll find it's not a paper there. It will lead you to a paper that is very, very technical, but it still does indicate that there's been a constant growth of the equator, at least for last 17 or 19 years.
But Neal, do you assert that the expansion is continuous, or could it be cyclic or
I would,
episodic?
first of all, I would never use the word expansion, because nothing expands in science. It's not a physical property of the universe. Thing may grow, but it can't expand unless you add another force to it, like heat.
Here's the point. They're taking the word expansion and they're basically literally interpreting it. So that's issue one. Okay, which is, you know, the playing the game with the word expansion.
Yeah, that's one of the problems I have with the words. I would prefer to be specific and also simple. But no, it's growth, and it's continuous, and it's ongoing, and it wouldn't change, because
you are going to assert that it's continuous growth.
Yeah, because it would have to grow backwards to not. So it's continuous. There may be some stutters along the way because something gets compressed, but essentially it's ongoing, and it's not only continuous, it's exponentially greater, just like the universe. The universe, and one of the things they discovered 12 or 13 or 15 years ago was that the universe was not slowing down in its quote expansion. It is not staying the same in its quote expansion. It is increasing exponentially. So, and I would take that as a clue to what is happening with the Earth. It's growing exponentially. And so, and that has to be ongoing. You can't reverse growth. That's why the use of the word expansion, which is what Sam Carey started with, and it's a slightly more romantic word, is a wrong word, because nothing expands without adding energy or adding something to it. This is growth. And it's ongoing, and it must be ongoing, because that's what growth is. My baby didn't grow backwards. Anything that grow, the crystal didn't lose its crystals unless you did something, chip it with a hammer or something. Growth is growth. Expansion has nothing to do. And in fact, nothing expands in the universe. There is no such concept unless you add energy to it. A gas may, quote, expand, but it doesn't become greater. Growth becomes greater. New matter is made and it grows. That's how that's how we have a universe. We don't have a universe by magic. It didn't suddenly burst into existence.
Okay, it looks like we've got a question from Cornelius. Cornelius, did you have a question?
Yeah, I did have a question. Basically, I missed the first part, and so I wasn't really sure whether this growth included an increase in mass or an increase in volume.
It increases in mass and volume.
Okay, so the additional atoms are created.
Exactly. And the beginning of that process is pair production.
Okay, the reason I was asking about mass and volume is because radiation decay would increase the volume, but it wouldn't necessarily increase the mass.
Exactly.
Okay, so you are saying that the mass is increasing as well.
Yes. As is the mass of the universe, and the mass of the sun, and the mass of all suns. I mean, we have these theories that cover things like suns, where we say, well, the sun is getting bigger, but it's not actually getting bigger. It's not increasing in mass. Who says? Who says? Because you say so. What is you have measurements? No, you don't have measurements. You just can't believe in a theory that says the sun is actually getting bigger. It's not only getting bigger, it's getting hotter.
Yeah.
I mean,
I understand the increase in mass in stars and that, and where they get their energy from. because basically if you're going to increase mass, you're condensing energy into mass. And I understand that process within
Well,
stars.
no, I
but
don't think we are. I don't think, and I would have to say, no, I don't think we understand that process. We have standard theory to go by. And if this is correct, standard theory is wrong. Mass is actually created. I mean, we have a sun that's throwing
I
out
agree.
400.
I agree. Mass was created. I agree.
Yeah.
Mass was created within stars.
Well,
I have no issue with that.
that's not
I
standard.
do.
That's not. I can tell you that's not standard theory.
Well, I didn't say I trusted in
Oh,
standard
okay.
theory. I said
Good.
I understand the increasing of mass in
But
stars.
also you
Modern
must
stars.
see that that has to be extrapolated out to everything. You cannot. I mean, it's one of the things that I ran into when I started this whole journey. I thought, well, I'm just going to show Sam Carey's mechanism, and it'll take me 3 years, and I'll write a book on it, and then that'll be the end of it, and goodbye. But once you realize that the Earth is growing, and all the clues point to it, then you must then make the next logical deduction. The next logical deduction is the Earth is a microcosm of the universe. Therefore, everything that applies to the Earth applies to everything in the universe. Therefore, our understanding of the universe is bass-ackwards. We think the universe was created in a magical flash, and it wasn't. It started very, very small by a simple process, a simple miracle given to us by nature or whatever, and that increased and, by the way, evolved, because that's also one of the processes of nature. It's not just life evolves, but matter evolves because it mixes together differently and it becomes slightly different. Then there are things that are added to it. Now, I'm not talking about particles, I'm talking about processes. Then suddenly you get, I mean, you need to get to a sun to get to helium. You need to, if you're just producing hydrogen atoms, all you're going to get is hydrogen atoms. You need to get those hydrogen atoms collected into a sun in order to get to helium. And then you can't really produce other atoms past that unless you fire them out into your solar system and then there collect them together into other atoms. Because and this whole idea that atoms come of our planet come from some supernova across the galaxy or somewhere is very theoretical and in some ways nonsensical, when in fact our sun is throwing out 400 million tons of matter into its solar system every single second. What is happening to all that stuff? Well, if there's a process that allows those particles, those protons and electrons to form into higher count atoms, then essentially a sun makes its own solar system. Well, you know, once you start trailing this theory down, it really changes everything we know.
Well, let's get back to the growing Earth theory. So we've discussed the objections on the website here. So I put the website back up here. So we've discussed their first one, which is high precision measurements disprove growth. Okay, so the next one is that they're objecting. They're saying that the subduction zones explain the expanding. I mean, that explains why the ocean floor is only 70 million years old, because all that crust is just going underneath the west coast of the United States, right. I guess is the argument. So how do you respond to
that? One of the ways that you, I mean, if you accept the subduction, and I accept the subduction concept at the left-hand side of the Ring of Fire, which is along Asia and along the northern area of the Australian plate. One of the ways that you can identify it and study it is that you look at the plate that's on the one side of the subduction zone, and then you look at the plate that's on the other side of the subduction zone. And if they are the same age, then there's not much subduction going on. If they are very different ages, that means that some plate has gone under the first plate, the abducting side, and it is a different age than the plate that's on the abducting side. So you can very easily identify if there is actually subduction going on at all. There is only one area of provable subduction on the Earth, and that is along Asia and down, curving down and up toward Alaska, and then kind of fading there. and then going down across the Australian plate, across the Pacific. It is not below the Australian plate. It is not anywhere in the South American area. It's not happening in the Atlantic. It's not happening in the Indian Ocean. Well, there might be some a few little things that are happening there, but very, very small. But you just measure each side. Now, because I'm
can you point to the, you have that map in the back of you. Can you point to those areas?
Well, okay.
So, I mean, the argument is that, so we see the spread happening on both sides of the Earth, but they're saying that
the spread is happening, but there's no subduction over there. The only subduction that's happening is here along this subduction zone.
Right? Well, that's where that's where they would expect it, right?
Yes, that's
it's very logical. That crust is being eaten up on the other side.
You can actually see the crust. You can see the sliding under. You can see it actually sliding under this plate. And by the way, 60 million years ago, when Australia started to come up, you see how it broke up this plate over here? I don't know if you can see it. I don't know if
yeah, we can see that.
This plate is broken up over here by the pushing up of this, because our new spreading area down in the Antarctic spread is one of the most aggressive spreads that went from the Pacific down into the Antarctic and pushed Australia away from Antarctica, okay, and pushed it up, and is crushing and mangling these plates over here and giving purchase to subduction right in here. By mangling these plates up and breaking them up, then purchase is given to subduction over here. Well,
why would subduction be happening over there? If the Earth is expanding, then there wouldn't need to be any reason for that to subduct.
If you have unequal forces anywhere, no matter what they are, then you're going to have a result. In other words, you can say, well, how can you have subduction in an Earth that's growing? Well, it really has to do with the amount of growth and what kind of growth is going on. You see the growth happening in the Atlantic. You see the growth happening here. If permission is given for subduction, and the plate is thicker here, this is the older 180 million year old plate, this is thicker plate than some of this newer plate over here, then it can subduct under it because there is a force that's pushing away. It's called gravity. In other words, wherever you have spreading, okay, you have a higher oceanic plate, and everything else is downhill from there. So your plate is in effect falling away from the rifting, okay, falling away. So there is pressure, not a tremendous amount of pressure, but certainly enough pressure if the opportunity is given for subduction to happen. You can see this in ice flows on the side of the river where not much is going on, but some bumping and crashing might drive a piece of ice under another piece of ice. That doesn't mean that there is an expansion or spreading out going on, but in certain areas, something like that can happen. But this is a very big area, and this is the oldest oceanic plate right here, so the thickest and the heaviest. So it's going to, if anything subducts, it's going to want to subduct. But if you just finish these lines off, okay, under here, you can see the extent of the subduction, because it isn't over here. So it can be in here, this area, subducted. Okay? That's it for the Earth. That's it. No other subduction. And there's nothing wrong with that. And that began 60 million years ago. How can you check that? Well, I'm going to have a video up soon that shows removing this from under here and measuring the plates until the age of the plates is exactly the same on one side as is on the other. And that's where it started. That started.
Well, what is going on the west coast of the United States? There's
nothing going on.
Nothing going on. Because we have, like, say, our Mount Rainier. That entire mountain range is theoretically due to the plate subducting underneath the. This is what we've all been told here on the west coast.
I understand that people are saying that, but this is the rift. Okay, it goes up the Pacific. Okay, and then it goes up the edge of the continental plate. So there is spreading this way, and they're spreading on this side, but it's held up by the fact that there's a continent sitting on top of it. So there's no subduction going on over here. You can say it, but it's not. It doesn't exist, right? Look at this.
This age here, this is like 60 million years ago. 60 million years ago, South America was along the rifting plate right there. So North America was along it, South America was along it. This was bent this way, this was over here, and these were together 60 million years ago. Then the spreading pushed or allowed the pushing, spreading of South America to move, but unfortunately or fortunately, the rift continued under the North American plate and it did not jump the line. So it's just, there's lots of activity here, lots of earthquake activity. Is it subduction? No. There's no sign of it. There's no measurement of it. There's no change in the age of the plate there. It's just continuous. Here's where the rifting comes out right there. So it just doesn't happen. It's easy to measure. You just get a ruler and they give it to you. The National Geographic Survey has all these ages. I didn't make this up. This is not my map.
Well, I think the objection that they're giving is that we can probe the mantle of the planet, and that they're saying that it supports that subduction picture. You know, we're around here in Seattle when they ever show.
Honestly, they're not describing a subduction in these areas. They're saying, you know what? One of the ways you do that is you show the maps and you show the subduction and you show the profiles of the seismic activity that's going on and how plate is going under other plate. There's no subduction under continental plate anywhere. The crust of the earth is the crust of the ocean is 2 miles thick. The crust of the continental plate is 40 miles thick. That's 2 miles going under 40 miles. That is a Cocker Spaniel going under a hippo. It can't go. There's no way for 2 miles to go under 40 miles. That continental plate is married, okay, to the asthenosphere in hardened rock. It may be ductile, that is softened, but it is not melted. So you can't take an oceanic plate that's only 2 miles thick and drive it under a 40-mile thick continental plate. It can't go. All those diagrams that you see on the internet that show subduction show plates that are similar sized. But the National Geographic Survey will tell you that the continental plate is between 35 and 40 miles thick, and the oceanic plate is about 2 miles thick. So if that's the case, why don't those diagrams match it? Why isn't there a 40-mile thick continental plate and a 2-mile thick oceanic plate, and somehow you're going to subduct underneath it and you can't do it? And believe me, I was one of those graphic artists that did some of those drawings for some of these people in some of these textbooks. And I would say, guys, but aren't you guys saying that the continental plate is thicker? Well, no, just let it slide under. Just do that. It's just BS. You know, it's one thing tries to explain another, and it doesn't. They don't match the facts. And the problem with all of this is you really have to track down the facts. You're not going to get once you have a society or a group of people that are convinced of something being a certain way, they will fight for that way no matter what. And I honestly don't blame them. You know,
science sociology with I think the fact that they want to debunk this theory is kind of interesting. That there's a site that says it's.
Can you come closer?
They're saying they're debunking. This website says we're debunking this theory.
Yeah.
You know, my question, to me, subduction, I never really thought.
Yeah, there's one of your. Look at that diagram there. That's great.
Subduction doesn't make any sense to me. I mean, what their explanation of these plates floating around on the surface of a boiling Earth, you know, to me, it never really made any sense. That's what you're saying.
You run into facts. 2%. I'm wrong. 4% of the asthenosphere, and I'm not talking about the mantle. 4% of the asthenosphere is molten. That's just a little section underneath the oceanic plate. It really hardly continues. You see that diagram there? You see that molten stuff under the continental plate? That ain't there. And that continental plate looks, I don't know, 3 times thicker than the oceanic plate. It's 40 miles thick. not because I say so, because they say so. And you can look it up. I mean, none of these, if I tell you a fact,
You're
I'm
still
sorry.
stuck on defending your position. Okay.
What was the first?
I mean, I'm hearing you just saying the same things over and over and over again.
You know, it's funny when something tends to be true, you do say it over and over again. I know I get to be boring that way.
Well, I sort of am of the opinion, and I was sort of saying this, I sort of agree with this whole idea because I don't think the plate tectonics theory makes sense. And the facts don't seem to really fit into that idea very well.
Well, I think
And
it's more than
so-
that. Plate tectonics. If you examine plate tectonics theory, all it is a description of plates moving around. It's not a theory. It's nothing. They say it's a tectonic theory. It's not. It's sort of like looking at the ice in the river and saying, okay, I got an ice tectonic theory. No, you're just describing the ice. That's all. There's no plate tectonic theory. There are plates.
I mean, I think this diagram is sort of like, I mean, you know, you could really criticize them on this diagram. They're saying things are happening under the crust of the earth, which they can't know.
That's a nonsense theory. Look at that picture. Oh, God.
Well, they're claiming that it exists when they can't actually know it.
I know.
I mean, it's
these diagrams are so preposterous that they you know, the difficulty that I have is to stop laughing all the time. I have a lot of trouble stopping.
What you have is an established theory that's basically fake science. Okay. So the real issue is, how do you deal with that?
Well, the problem is this. And you're starting to see it. And believe me, there are far more evidences and proofs and facts to support it. We haven't gotten necessarily into them, and they're worth discussing. The problem is that once you get to the end of that, then somebody says, but what about the mechanism? And that's what we did earlier, and which is a perfectly logical place to go, because once you get past all the other stuff and everybody says, yeah, well, we can't prove that mountains are any more than 60 million years old, even though we believe it, and we can't prove this, and this fish fossil thing, I don't understand the fish fossil thing, blah, blah, blah. When you get past all that, and we don't understand all that, you get past that, then somebody says, what about the mechanism? And that's what took me the 30 years. You know, you have to go there. And that's what I did. And that's what this, you know, underneath this all, and I wait for the physicists to show up so that I can discuss this. Because basically it has to do with a theory of how the universe was made.
They don't want to discuss it, Neal. That's the whole point. That's the point. They don't want to discuss it. It's easier to suppress it by putting out websites like the one that we have on this page than it is to address the issue.
Yeah.
They don't want to address the issue.
Yeah.
Because it upsets their paradigm.
I see this number 5. It says geological data from ancient Earth shows consistency. Unbelievably nonsense. I mean, if you read,
what about something that they can say that's an argument that looks like it's plausible?
What about number 4?
What they have is that they made a measurement and it showed there's no expansion. That's the only argument they have. The rest of it, I think, is just their opinion.
Yeah.
The only fact they have is the measurement that they couldn't measure any expansion.
Right.
The rest of it looks like it's just fake.
Well, let me just say this, guys. There's so many things that come from this that make you look at science differently. For example, where did salt come from? The assumption that salt came from dried up oceans assumes that there were dried up oceans that were filled with salt.
Yes. Well, let's try and. I think that you covered that once again last week.
Maybe.
So, like we said, we covered a lot of evidence for this to happen. Mm-hmm. So, but what about like this? They have another objection here, which is they're using paleomagnetism, which is that they're studying the direction of the poles over time, and it's known that the magnetic field has switched polarity actually fairly regularly.
Sure.
And they're saying that by studying the rocks and looking at the direction of the magnetism, they're calculating that the Earth's size really hasn't changed very much. So that sounds plausible.
So it's not so much that we're pointing to the magnetism. we're pointing to their calculations, which is like, that's what they do, you know, I don't know, in their notebooks and on the side. There's nothing about that that has a proof in it. They're just saying, okay, there's magnetic reversals. Okay, we know that, right? In fact, that's one of the ways we find the ages of the deep oceans, is that we check the magnetic reversals. That was a thing that happened all through the 60s and on into today. So what? What's the point? There is no point.
Well, I would think that the magnetic reversal is on your side of the ledger, because they have no real explanation for it. It's just something that happens.
No, it's a mystery of how it happens. We know that. But that's another thing too, is that they'll throw stuff at you like.
What?
Go ahead.
You know how it happens?
Say it again.
Do you know how the magnetic reversals happen?
I have no idea. Guys, if you guys think I'm God here, I'm not. I'm not God.
Neither do they. Neither do they. They don't either.
No idea.
Well, the objection is not, it doesn't have anything to do. I think everybody assumes that those happen.
It's their calculations.
But what they're doing is that they're calculating like the specific direction. And if the Earth was smaller, I mean, it would have probably sharper angles.
No, because there are no sharper angles.
Versus in a larger, if it got larger, then I could see how they might be able to calculate the size of the Earth.
There's no angles to magnetism. It doesn't. No, it's just bullshit.
Well, no. In magnetic rock, there's going to be a specific north-south vector that's definitely measurable.
Yeah, sure, absolutely.
So I presume they're looking at that. So they're although I'm not sure what they're doing, because like this is the first time I've seen this website as well. But it looks like that's what they're saying.
What else have they got? I'll take anything. I'd like to get one solid argument, get me off of this, so I can go about my business. But I haven't heard anything.
Well, so let's just review what their objections are.
Is that they can't measure any expansion.
Yeah, so that's their number one. High precision measurements disprove growth. So satellite measurements
that's the only
don't do that.
And yet they're constantly talking about earthquakes and the cracks in the earth splitting open, and somehow they magically move apart, and you get these big fissures in between, and then you get sinkholes and all the rest of it, and you see all these evidences.
One question that I have is that even the continental drift people say that the Atlantic is expanding about the rate of your fingernail.
Yeah.
Which would presume that they can measure that. So. Yeah.
And look at it. They
should be able to measure an expansion on the other side of the Earth on the Pacific, right? That's really all they would have to do.
Look at the crustal age map, okay, and say, okay, we'll look at the Atlantic and it's spreading, and we'll look at the Pacific and we'll say, okay, up in the north, okay, by North America and Asia, we see there's subduction going on. Now we look at the Australian plate across the ocean to the South American plate, and there's no subduction going on, and there's only spreading. Only spreading. So how do you explain the subduction up in the front? Well, there's twice as much spreading up in the top, and there's half the amount, but they're still spreading. So now you have, if you look at the southern half of the whole globe, there is no subduction, and it's only spreading. Only spreading. Now, I'm willing to take anybody's opinion, anybody's view. You can sit with a ruler and measure the spreads. There is spreading in the southern hemisphere, completely not obscured by some amount of subduction as there is in the northern hemisphere, which is only half of it. And by the way, if you start measuring these things backward, that subduction up there only started 60 million years ago. It didn't start 180 million years ago. So there's just so much, guys. Factually,
but we have the
it's their stuff. I didn't travel across the ocean and measure this stuff. It's their maps.
In the southern hemisphere. Let's look at the southern hemisphere next to South America there.
Yep.
So the conventional people would say that, in fact, there is subduction going on there on the west coast, and that's why they got the big, gigantic mountains built up in Peru and such. That's one of the things they're saying, that there's kind of a collision going on there, it's building up mountains. That's what they would say. So what do you say to that?
Okay, well, let's talk about mountains. Okay, one of the things they say, well, up until recently, they haven't actually ascribed mountain building to subduction. They have ascribed mountain building to continents colliding with each other. Okay, and only recently are they attributing some mountain building, like especially in South. They seem to provide different reasons in different areas. Like, how do you then, if you use that logic, how do you explain the Rocky Mountains or the Appalachians? Because they're clearly no continents crashing into North America. And because those mountains are only 60 to 80 million years old, I mean, Appalachians are really 60 million years old, so we'll just say 60. There's no continents crashing into North America anywhere 60 million years ago and up until today. So what is mountain building? Well, I'm going to tell you what mountain building is according to this theory because it's a lot of fun. Okay, since the continental crust is now 40 miles thick, 35 to 40 miles thick. It was not 180 million years ago. I have to understand it was probably only 2 miles thick 180 million years ago, because that seems to be what you need in order to have the rifting and spreading. You need to seem to have a thin crust, but we'll assume for the moment that the crust got thicker, or not the whole Earth, just the continental crust got thicker. If you have a stiff granitic plate on a ball, and the ball gets bigger, then that plate must recurve to a flatter plane as the Earth grows. So what happens to the upper 2 miles or 3 miles is they must buckle and fold because they're recurving. The bottom part may be stretching a little bit, the middle is staying the same, but the top is recurving, and that's how you get mountains. One of the ways you can see that is by putting your hand on the table, or cupping your hand on the table and then lowering your hand to flatten on the table and looking at your knuckles, and you will see mountain ranges. That's what happens on the Earth. Mountain ranges do not come from continents colliding into one another, because continents cannot collide into one another. They have a skirt of basaltic rock around them, and they can't touch each other. They can't get to each other. No,
is that really explaining what's going on the west coast of North America and South America? I mean, it's kind of suspicious that you got this gigantic chain of mountains all up and down that entire area. The subductionists would say it's because there's subduction, right?
Well, that's what subductionists would say now, when they lost the fight about continents crashing into one another. But that spreading essentially could add to the recurving process. In other words, if the pressure, not on North America, because the pressure doesn't exist there on North America, there's only a spreading pressure in North America where there's rifting under North America. So nothing can happen in North America. But in South America, there does seem to be a pushing or a holding. So if you have, let's say, we'll take the example of your hand flattening, and you hold something against your hand, you can actually create additional buckling by having pressure against it. I would not argue against the idea that pressure against it may add to the buckling, okay, of a 40-mile thick plate recurving. But if you look at the length of South America from the top to the bottom, there's a recurving from the top to the bottom that is massively larger than almost across any continent, or except for Asia, of course. And that buckling in Asia happens in the middle. So this could happen along the edge simply from recurving, but added pressure to the side might add to it. But finding subduction is actually very easy, okay? All you got to do is set your seismometers to when there's a local earthquake. You measure any continental oceanic plate going down, that might be going down, and you can see it in your seismometers or seismographic printouts, and it goes under something. You can see it. It's not there. If it were there, it would be printed in the New York Times. Well, once the New York Times reprints again. And I'm just saying, if it were there, you would see evidence. You would be able to look it up on the internet and see this subduction going on. They would have diagrams for it. They're not there. They don't have them.
I think that's what they're saying with 3. Now, I've never looked
Okay.
at it, but they're saying that that they have imaged the lithosphere, and it shows that the mantle of the planet supports consumption. That's what they're saying.
Yeah, they can say that about the area that
actually look at it. Well, they should find subduction under the under South America.
But they don't. There is no subduction under continental plate. They should. They can't. It's not there. They can find subduction in the middle of the ocean because it's 2-mile thick plate going under 2-mile thick plate. That is and especially if one area of the plate is broken up and weakened, okay, that can happen. But to go under 40 miles thick of plate, it's not possible. I mean, I'm not saying that it doesn't happen. I'm saying it's impossible for it to happen. It cannot happen physically. There's no such, you can't put 2 miles under 40 miles. It doesn't go. And there's no indication it does. The only place where subduction happens is in the mid-ocean, where oceanic plate goes under oceanic plate. No oceanic plate goes under continental plate. And if there was a learned geologist there, he would tell you that. This is something that, I don't even know, that discussion shouldn't even happen. That shouldn't even be a point. I don't know where. If you read this, they're not saying it goes under a continental plate. They're saying that it happens. And I agree that in the Western Pacific, yes, it does happen. That oceanic plate can go under oceanic plate under the right conditions. And it happened there. And maybe in the future it'll happen more. Maybe that's a natural phenomenon. But right now, no. Right now we have the oldest oceanic plate on Earth sitting right there in a triangle, unsubducted. There is no oceanic plate on the planet Earth that is older than that. And that oceanic plate, if you look at the right-hand side of it, existed right at the west coast of North America. So the first spreading of oceanic plate happened on the east coast and the west coast of North America. We know that happened on the east coast, but it also happened on the west coast. That triangle was over there, or North America was over by that triangle and spread away. And that is the oldest oceanic plate in the Pacific, and that is the oldest oceanic plate in the Atlantic, and that is the oldest oceanic plate on Earth. There is none older. There is not 1 square foot anywhere on Earth that is older than that. To say that there is older plate, to say that it magically disappeared and it was eaten over here under this plate, all you have to do is look at the direction of these pullaways, and you can see that you can take the same plate and stick it under there and pull that away, and it didn't exist. There's no magical place for it to go, just as there are no magical ancient mountains. It's just theory, not fact. And that's,
we're getting towards the end here. I just want to say, I find this all very convincing.
Well,
and
I got to tell you, you're going to have to go out and tell some more people, because and
hold on, Neal, hold on.
Sure.
The issue here, and from my point of view, is, and I really don't think that it was correct or proper of Franklin to put up this website claiming to debunk, because I don't think that's really, your job to.
No. Believe me, it is. I love it. I love it. I honestly love it, because
Please, Neal, please.
Yes.
You're. To me, it just confuses the issues. Okay. All right. You presented your case, and your case was pretty. I think is a pretty good case. Okay. I'm sorry. I just think there's just too much to, there are too many issues, there are too many points that people could get confused over by listening to all this back and forth going on. And I think you need to.
Well, it is a discussion.
What you're saying. What I don't understand is, to me, the real problem is you got these big cracks in the surface of the Earth. Why are they there? Okay, to me, that's the big question. Okay, and then now the argument gets down to the fine points of, well, we can explain it by this and by that. And to me, that's all fine points. I want to know why there are these big cracks in the surface of the Earth.
Because the crust is spreading. Simple.
That seems obvious, but it seems to me the scientific community does idea issue.
Believe me,
Well,
your wishes are well received, and I appreciate it. But the truth of the matter is, this is a big battle. I'm not going to win it by the good wishes of people that find it to be ridiculous that it goes the other way. We can only win it by finding out all the facts and for scientific discovery to continue
Well, you're
to
getting
support
too
this.
involved in the details, Neal. You need to look at the big picture.
Well, I think I do both look at the big picture and get involved in the details
Well,
because
you are looking at the big picture, but it's just too confusing. There are too many issues.
oh well,
You
shit happens,
understand what I'm
and
trying to say?
I can't avoid it. Look
I
at this
realize
whole
that,
thing.
but
By the way, Sam Carey's theory was heading for oblivion, and I was doing a book on this, and I had come up with a mechanism, and I satisfied myself, and I was doing the book, and too many more details came up, as you say, many more details came up, and there was so much. But then I realized that I actually have a studio that can do computer imaging, that I can create animations. And so I realized, well, okay, the best thing I can do right at the beginning is to do animations that show all this, okay? Because that's clear to people. It's graphic. It's easy to see, okay?
well, that
So,
goes back to the issue of why are there these big cracks in the surface of the Earth?
yeah. Well, anyway,
I think
the point is that
we need to find some way.
I did the animations, those animations that presented, and it reopened the discussion. So the first goal was to reopen the discussion, and now we have an active discussion. Now we have to prove it finally. And if somebody has a guidebook, I'll be glad to read it. I don't know
Well, I
what the
think
answer is.
it has to be. I mean, in our discussion here, I think it needs to be proven conclusively. Like we mentioned that they admit that they can measure the spreading in the Atlantic, and it's about the growth of your fingernail. Now, I would think that if they could measure the spreading between the North American and China, that would be a done deal, right? Because if it's expanding in both places, then the only way that can be explained is if the entire Earth is expanding. So I would go look and see, because actually I think they probably can do millimeter measurements, and maybe that article I was looking at, maybe they're wrong, but I would think that this kind of measurement should be possible.
Yep.
So we should be able to directly measure the expansion. And if you could just clearly show that, if you could show that, South America is moving away from China at the pace of your fingernails growth, then there would be nowhere anyone could escape, right? Because if it's expanding on both sides, there's only one way it can be doing that.
That's really. It would be very nice if somebody had a tape measure that could do that, but nobody seems to have it. And
no, I think they probably can. I think technically, that's why I would encourage you to look at that kind of technical side of it.
But I have.
Well, take a look at it.
And I can tell you that there's so many people who are against the theory that you really can't get a good read. You really can't get a good read. There's a guy in China who is doing the calculations, and he keeps on going over them, and he feels he gets it. He understands the growing Earth, but he needs to prove it more and more. And so at some point, somebody's going to get it. Me, you think I'm going to get it? I don't think so. I'm busy. I have a life. I have things to do. I have to depend on the scientific community. And the only way I can get anything out of them is just beat them over the head constantly and say, okay, you guys are wrong. You don't know what you're doing. Your instruments are wrong. You believe in your instruments like a religion, and it's bullshit. And just keep on wearing at them, because I don't have the facility. I have the facility to make the animations. I have the facility to study. I have the facility to do all these things. But, I look at history, and I look at all the scientists who have come up with theories, and they've waited for 10, 20, 15 years, whatever,
for them to be proved by somebody else, never by themselves. They never prove their own theory. There's always somebody else out there that performs this experiment that makes the theory happen. I can do what I can do. Okay, I can provide answers to any questions. I can provide facts. I can do all these things. I can't go and measure the earth. I can't do it. I know that people have measured the earth and they disagree. Okay. And then they present their instruments as though they were objects of religious worship, and they're perfect, but they're not. I know enough about instrumentation to know that they're not. They're simply not. The equator expanding, then as soon as you say, well, okay, these people say the equator is expanding, then somebody comes up with a theory that explains how the equator can be expanding and why this can't be true. And so then you're presented with, it has to do with glacial melting or some. So every clue, by the way, every fact that you give is debated and debunked, and people attack it, and they say, how can people argue against differentiation creating a full crust and then the crust break? How can they argue against no fish fossils in the deep oceans until 70 million years ago?
They don't want to believe it.
Yes, there you go.
They do not want to believe it. Okay, so the point is, what you have are these big cracks in the surface of the earth. Okay, this is my view of it. You got these big cracks in the surface of the earth, and all this stuff is coming out of these cracks. Yeah. Okay, why is that happening? Okay, they have an answer that really isn't a very good answer, but they want to stick to it. Yeah, that's really what it boils down to.
Yeah,
that's it. I mean, that's my perception of it.
They have they have a Pangea theory that, according to science, would have been 800 feet underwater, and it would have looked like the Philippine Islands. And they fight that.
Thing doesn't make any sense. I agree.
They have dinosaurs. Listen to me. They have dinosaurs that weighed.
They don't want to listen.
They have dinosaurs that weigh 60 tons. That would be the same as a 6-ton elephant carrying 10 dinosaurs on his back. Makes no sense. All of this makes no sense. Tyrannosaurus Rex. Tyrannosaurus Rex was too big to run. Was too big to run. I'm sorry.
They're not listening. That's the point. That's the problem. That's the issue. They are not listening.
Shit happens.
Well, I think everybody has to, everyone needs to listen. And so that's why here in the CNPS, we encourage all kinds of discussions. And that's one of the reasons why I needed to go see whether we could find what other people are saying about this. That's not my website or anything like that, but it's just interesting to see that. Although it's kind of curious that in my little search of trying to debunk this thing, that I could really actually only find one website. I could find a couple other forums, but no real website. And this real website doesn't really go into very much detail.
No.
So in that way,
I'm just saying, guys, let me just tell you this. This fight is going to be won. This fight is going to be won, and this is going to be the science of the future. And it's just going to take digging in and doing it. And I've been in fights similar to this before, having to do with other things, and I know how it goes. And it's just not an easy process. It's just not an easy process.
Well,
but guess what? We got to change the world.
Do you not agree with my perception that the real issue is why are there cracks in the surface of the earth?
I agree that is one of the most profound basic observations that Samuel Warren Carey presented in the 1960s, and it was part of the discovery. We honestly all know that, and all that's been happening is that they've been making excuses for that for the last decades, and all those excuses are BS. They really are. And there's nothing I can do about it. Let me just tell you this. Guys, before the ocean started to spread, the continents were spreading. You can take a plane across the United States and you can look out of that plane and look down, and you will see oceanic spreads that are not oceanic spreads, but shallow sea spreads all across America, all across the middle of America. You will see a ridge, you'll see flat land, then you'll see a ridge that will go straight down, then you'll see flat land in the middle, then it rises up on the other side, and then there's flat land above that. That is a tectonic spread that happened before 180 million years ago on the continental plate when the Earth was smaller. And they're all over the continental plate. They look exactly the same as the deep oceans, and they're there for people to look at. Do people look at them? Do people observe them? No. Do they talk about them? What are those? Oh, yeah, they're ridges. No, they're not ridges. They're spreads. It's everywhere.
It's
All the
everywhere.
proofs are everywhere.
But they don't
Well, I
have
think
an
we are
answer.
getting towards the top of the hour here. So
Neal, they don't have an answer, so they have to give a story that sounds plausible. Okay. And then when you object to their story, they have to suppress it because it conflicts with their implausible story.
Let me just say this, guys. One last little thought. I don't really believe in conspiracies. I think that's all bullshit. I just think it's the honored opponents that are against me, and I'm going to win and they're going to lose not because I'm better, but because they're wrong. It's a wrong direction and we have to undo it. And it's as simple as that. And you know what? When it happens, they will be the first to jump on the bandwagon and say, I kind of thought that all along.
it might be. Okay, so we're getting at the top of the hour here. So, Neal, I wanted to thank you for coming to our meeting again and answering our questions about the growing Earth theory, although I think you're kind of preaching to the choir here. So I think
what the hell's wrong with you guys?
I think everybody, most of the people here are all nodding their head in agreement. So, but we did have a good objection from Hans about he's trying to challenge you about the expansion, and we went into some of the physics behind how that could possibly happen.
I'm sorry,
but that's all right.
A bunch of physicists together and have a good time.
This is what us physicists do. We try and figure out how pair production works, and although for the purposes of your theory, if you can agree that pair production works, then that is the core of where you think the matter comes from. So if you need an explanation, there's one. Although
there are ramifications to that pair production that's certainly worth a discussion, because in the end, it is the last major discussion of the whole thing. I mean, all the rest of it is visual evidence and measuring and all the rest of it. Pair production.
Personally, just from a philosophical standpoint, just because you can't explain the mechanism of expansion, that's not actually an argument against the expansion happening. It just means you can't explain that part.
Well, that may be true, but I can't explain it. And that's what I gave.